Yeah, hello, you're welcome to Master T Math class. In this live class, we want to look at a topic in mathematics known as trigonometry, and we are looking at basic trigonometric ratio. And before we look at that, let's state what is called Pythagoras theorem. We have something called Pythagoras theorem, and we need to know the theorem and know the application. So Pythagoras theorem, this states that Pythagoras theorem states that in any right angle triangle, in any right angle triangle, the square of the hypotenuse, the square of the hypotenuse is equal to the sum of the squares of the two other sides. So here we have the Pythagoras theorem. So we have the Pythagoras theorem, and it states that in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the two other sides. Now, let's demonstrate this in a diagram. We have the right angle triangle. What makes this triangle to be right angle is angle 90 degree here. So this angle here is angle 90 degree. Then let's label this as A, B, and C. Now, the side that is facing this 90 degree, which is C here, is the hypotenuse. So any side facing the right angle, the triangle might be drawn in any way. So if it is drawn this way, and this angle is labeled as angle 90 degrees, so this side facing this angle will be the hypotenuse. So if this is A, B, C, so the letter C here is the hypotenuse. So whichever way the triangle is being drawn, so it doesn't matter whether it has the side, is the longest one or not, in as much as we have angle 90 degree, even if it is here, that the angle 90 degrees. One facing this angle here will be the hypotenuse. So if this is A, B, then this is C. And C here is the hypotenuse here. Now, and A and B here are the two other sides. So what this theorem is saying is that we have C squared now, which is the hypotenuse. So we have hypotenuse square is now equals to the sum of the squares. That's A squared plus B squared. Sum of the squares of the other two sides. So here we need to establish and know how to use Pythagoras theorem. Now, if we are given this triangle now, which is a right angle triangle, and this side is 3, this side is 4, and this side is x, which is missing. Since here we have a right angle triangle, we can get the side missing using Pythagoras theorem. And from here, the letter x we are finding here face the right angle, which means is the hypotenuse. So we can apply and say the hypotenuse square equals to the sum of the squares of the other side. That means we have 3 square plus 4 square. That is here, this becomes x square equals to 3 square, that's 9, plus 4 square, that's 16. And that gives us x square equals to 25. So taking square root on both sides, here remain x, then here remain 5. So x here is 5. And we call something Pythagorean's triple. Pythagorean's triple. So when we have a Pythagoras triple, is we have 3 numbers which satisfy Pythagoras theorem. So by Pythagorean's triple, we mean that we have 3 numbers that satisfy Pythagoras theorem. Like this one, we have 3, 4, 5. So these are Pythagoras triple. And the multiple of a Pythagoras triple is also a Pythagoras triple. For instance, here, the multiple of these numbers, here we have 6, 8, 10. This also is a Pythagoras triple. The multiple of this again, which is 9, 12, 15, also Pythagoras triple. So that is that about Pythagoras theorem. Now, any of the side might be missing actually. So, and you can find it using the theorem. In any right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the two other sides. So that's Pythagoras theorem. Now, here, let's look at the basic trig ratio that we have. So we have the basic trig ratio, and we have sine, cosine, and tangent. And we can, the ratio for sine, we can use the acronym SO. Then for cos, we use car. Then for tan, we use twa. Here it means that we have sine of the angle equals to opposite over hypotenuse. And here, car means we have cos, which is cosine, equals to adjacent over hypotenuse. And here we have twa, which indicates we have tan, tangent, equals to opposite over adjacent. Now, also this is applicable to a right angle triangle. Now, let's look at a right angle triangle like this. And this angle is 90 degrees. Now, let's still label this as A, B, C. Of course, C here is the hypotenuse. Well, either of A and B could be opposite or adjacent, depending on where the angle is given. So if the angle is given as this, which is theta here, it means the opposite to theta here will be A, why the adjacent to theta will be b. But if the angle is given here, let's say we have alpha here, the opposite of this alpha here is b, while its adjacent is a. So hypotenuse is always constant. The one facing the right angle is the hypotenuse. But any of the other two sides can be either opposite or adjacent, depending on where the angle is given. So the one facing the angle directly is the opposite of the angle, while the other one will be the adjacent. Now, for theta, A is the opposite, while B is the adjacent. And for alpha, B is the opposite and A is the adjacent. Now, let's list out the trig ratio for this. Now, for theta, we have sine theta now. Will now be given as, that's opposite of hypotenuse. Opposite of theta here is A, and hypotenuse is C. So we have A over C. Then we have cos theta. Also, cos is adjacent over hypotenuse, and adjacent is B over C. Then tan theta, that's opposite over adjacent, and this is opposite over adjacent. So that's A over B. So this is for theta. Now, the same way, we can list that of alpha. That is, when we consider the angle alpha now, we can say that sine alpha is now equals to the opposite of alpha. That's sine is opposite of hypotenuse. So that will be opposite, which is B over C. Then also cos alpha, here, cos is adjacent over hypotenuse. So this is adjacent of alpha, that's A, then over C. Then we have tan alpha. Here now, tan is opposite over adjacent, that's B over A. So here we have the basic trig ratio and how to apply them here on the board. Now, let's look at the question here to demonstrate and link this with what we have in our Pythagoras theorem. Now, given tan theta to be 3 over 4, now find the value of cos theta plus sin theta. Now, let's use this as an example here. Yeah, solution from here now. Once we are given this, we understand that since tan theta equals to 3 over 4, it means since tan theta is always opposite over adjacent. Now, what it means is that here 3 is serving as opposite, while 4 here is serving as adjacent. Now, something is missing there, which is hypotenuse. Of course, when you put it in a right angle triangle, we are going to have angle 90 degree here. And let's say theta is here. And 3 here is the opposite. So 3 here will be facing the theta, which is 3 here. Then also 4 here is the adjacent. Then something is missing here, which is hypotenuse. We can call it x. So from Pythagoras theorem, x squared equals to 3 squared plus 4 squared, which implies x squared equals to 9 plus 16, that's 25. That means square root both sides, x equals to 5. Now that the hypotenuse equals to 5, then you have to find the value of cos theta plus sin theta. Now, what is cos theta from here? We can write it out as cos theta. Cos is adjacent over hypotenuse. Cos theta will now be 4 over 5. Then sin theta, this is opposite over hypotenuse. And the opposite is 3, that's 3 over 5. Then, what we are evaluating now, which is now cos theta plus sin theta, will now be equals to 4 over 5 plus 3 over 5. And the SCM is 5. So this will become 4 plus 3, and which is still 7 over 5, which is now 1 whole number 2 over 5. So that is that. Now, this is one of the common question on this basic trig ratio. So that is that. Then also, let's look at some special angles. We have some special angles, and those special angles we can evaluate, we can solve problem on them without the use of calculators and table. So they are special angles. So we have special angles of 30 degrees and 60 degrees. So let's look at this first. Let's derive that special angle here. We want to consider an equilateral triangle of side 2 units. So equilateral triangle has all the sides equal. So side 2 units. This side is 2, this side is 2, this side is 2. And don't forget that all the angles are also equal. So this 60 degrees, 60 degrees, 60 degrees. We want to derive that special triangle now. We now want to draw a bisector of this angle that will touch this line. Of course, it will bisect this angle. It means here, this angle will now be 30 degrees. This angle will now be 30 degrees. So which add up to 60. And this angle meets here at 90 degrees. Now, don't forget that this line as well will be bisected. Everything was 2 before. Now we can divide it now, and this is 1, this is 1. Now, when you look at this now, we have two similar right angle triangle, two congruent right angle triangle. Now, we can bring out any one. Let's take this one out, and we have this as this, and we have this angle as 90 here. Then this angle here, we have it as 60 degrees here. This is 30 degrees. Of course, this is 2, and we have this as 1. Now, let's find this missing here as x now. Okay? The same thing we use is Pythagoras theorem. 2 is the hypotenuse, and x here is one of the sides. So if I want to find that, we can just say directly x squared will now be 2 squared minus 1 squared. Yes, because it's one of the other side we are finding. So once hypotenuse comes here, the minus will be there. So here we have x squared equals to 4, 2 squared is 4 minus 1, that's 3. So taking the square root on both sides, we have x equals to root 3. Now, here this side now is simply same thing as root 3. So we can put root 3 here. Now, we can use this right angle triangle now to find the ratio of this special angle of 60 degree and 30 degree. Now, let's check that from here. So we discover that here now, we can find this for sine 60 degrees. We have sine 60 degrees. Don't forget sine, opposite over hypotenuse. That's why we have SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. And opposite of 60, that's root 3. So that's root 3 over the hypotenuse here is facing the right angle, which is 2. So that's root 3 over 2. And also cos 60. Cos 60 degrees, we have cos as adjacent over hypotenuse. And adjacent of 60 is 1. So that's 1 over 2. So cos 60 is half. And also we have tan opposite over adjacent. So you can say tan 60 degree is equals to opposite of over adjacent. That's root 3 over 1, which is still same thing as root 3. So that's for 60 degrees, okay? Now, also for 30 degree, let's write it there. We can say sine 30 degrees, sine of 30. Let's put this one here. So sine opposite of 30 is 1. So opposite of 30 is 1 here. and hypotenuse is still 2. So we have 1 over 2. Then cos 30 degrees. Also, we have adjacent of 30 degrees, that's root 3, then over 2. Then tan 30 degrees, that's opposite over adjacent. Opposite is 1, adjacent is root 3, so 1 over root 3. So here we have the special angle of 30 degrees and 60 degrees. So without the use of table or calculator, we can solve problem on this. You can solve problem on this. Now let's look at one question to demonstrate this. To solve question here without the use of table or calculator, we have this particular question here that says simplify simplify 2 tan 60 degrees plus cos 30 degrees, all divided by sine 60 degrees. Without the use of mathematical table or calculator now. Solution here, all we need to know is the special triangle that we have. So we can draw the triangle for 60 and 30. Sorry. So let's draw any of the triangle. So let's call this as 60, this as 30, and this as 2, this is 1, this is root 3. So what we need here, we can state it out. We need tan 60, and tan 60 here give us tan opposite over adjacent, and opposite over adjacent here, that's root 3 over 1, that's root 3. So you are going to be needing cos 30 degrees, and cos 30 is 30 up here. Cos is adjacent over hypotenuse, and adjacent of 30 is root 3. So that's root 3 over 2. Hypotenuse is 2 because it's 90 degrees. And also we need sine 60. Don't forget sine is opposite over hypotenuse, and 60 is here. So this is 60, that's opposite over hypotenuse. That's root 3 over 2 as well. Now, when we substitute here, we have 2 times tan 60 now, that's root 3. Then plus cos 30, and cos 30 is root 3 over 2. Then all divided by sine 60, which is still root 3 over 2. Then now, all we need to do is to simplify this anyhow we want it. So what we have up here, you can say this will become 2 root 3 plus root 3 over 2, then all divided by root 3 over 2. So we can decide to bring this fraction up together as one fraction before we divide. That is, here the LCM up is 2. So now 1 goes into, that's 2. 2 times 2 root 2, that's 4 root 2 now. Then plus here we still have root 3 now. Then we can change this as divided by root 3 over 2. Okay, this division here is same thing as division like this. Then what happened next? Here we have 4 root 3 plus root 3. That's same thing as 5 root 3. Then over 2. Then this division change to multiplication. 2 will go up, then root 3 come down. That is, here 2 cancel each other, root 3 cancel each other, and simply here the answer is 5. So that is that. So you are watching us here at Master T Math Class. You can follow us for more videos and share this video as well. So that's one of the application of this particular trigonometry of special angles of 60 degree and 30 degree. Okay, so don't forget to share this video and like this video. Now, there's still another special angle of 45 degrees. And let's look at how that is derived before we round up in this class. So, when we have an isosceles right angle triangle of side of a equal side, 1 unit. So we have a right angle which is isosceles of this is the right angle, and this side that are equal are 1 unit. Now, of course, if this is right angle and this is isosceles triangle, this base angle, of course, will be equal. And here, of course, they are equal, 45 degree, 45 degree. Now, this is 1, 1. Of course, x here is the hypotenuse. So we can now say x squared will now be 1 square plus 1 square. And that will give us x squared equals to 2. That means x is now equals to root 2. Now, it means this side is root 2. So now we can find the ratio for 45 now. For sine 45 degrees, we are going to have sine is opposite over hypotenuse, 1 over root 2. For cos 45 degree, we are going to have adjacent. When you consider this, adjacent over hypotenuse, still 1 over root 2. And for tan 45 degrees, we are going to have opposite over adjacent. That's 1 over 1, which is still 1. So these are the ratio for special angle of 45 degrees. Okay? So that is that. Now, we can still apply this to some questions. So, there are some questions also that will be given without the use of table or calculator. We just need to use this ratio and simplify the given problem. Now, you have thus come so far in this class. I believe you have learned something. If yes, subscribe and don't miss out on our next video. And thank you for watching. See you next class. And bye for now.